Hello students, welcome to this session on the topic electrochemistry. So in this session the subtopics covered will be ionic mobility and ionic conductance, Kohlrausch law and its significance. So in this session we are using the term infinite dilution many times. What is infinite dilution? So we know that dilution means if we add a water or a solvent to a solution, it gets diluted, that is, its concentration decreases. A weak electrolyte, that is, electrolyte which undergoes partial ionization, is known as weak electrolyte. And we know the ionization of weak electrolyte increases with increase in dilution. That is, more number of ions will be formed and conductance will increase on dilution. So, if we go on adding water or solvent, the solution will get diluted and a state is reached where on further dilution there will be no change in conductance. Since all the electrolyte have ionized, so maximum number of ions are already formed. So hence there will be no change in conductance on further dilution. So this state of solution is known as solution at infinite dilution. And the conductance at this point is called a limiting conductance. It may be equivalent conductance or molar conductance. It will be called as limiting equivalent conductance or limiting molar conductance. So now with this, let us move on to the topic ionic mobility and ionic conductance. So it was observed that molar conductance of HCl at infinite dilution is more than 3 times that of sodium chloride. So in these two electrolyte, chloride ion is common. So it indicates that the speed of hydrogen ion is more than 3 times the speed of sodium ion. So it gives the information that each ion will move with different speed or velocity under the potential applied. So thus a term ionic mobility was introduced. So ionic mobility, the symbol is U. It is defined as the distance travelled by an ion per second under a potential gradient of 1 volt per centimeter. So under this condition, the distance travelled by an ion per second is called ionic mobility. Also it was observed that the conductance of an ion, that is ionic conductance at infinite dilution, is directly proportional to its ionic mobility, and the proportionality constant is written as F. F is Faraday. So the proportionality constant is equal to the charge on 1 gram equivalent of the ions under the potential gradient of 1 volt per centimeter, and which is equal to 96,500 coulombs of charge. So F is Faraday's constant. So lambda naught plus is the ionic conductance of cation at infinite dilution instead of 0. So the symbol infinity can also be used. So lambda naught plus is the ionic conductance of cation and lambda naught minus is ionic conductance of anion at infinite dilution, where U naught plus and U naught minus are the ionic mobilities of cation and anion respectively. Now let us see what is Kohlrausch law and its significance. So the law is also known as law of independent migration. So Kohlrausch observed that the molar conductance at infinite dilution for the salt pair like sodium chloride and potassium chloride, in which anion is common, and sodium bromide and potassium bromide, here also anion is common. So the difference between the ionic conductance of sodium ion and potassium ion is found to be constant. In both the pairs it is constant irrespective of the associated anions. So it indicates that the mobility of sodium ion and potassium ions at infinite dilution is not influenced by the nature of counter ions. So with this observation, Kohlrausch suggested that at infinite dilution, when dissociation is complete, each ion makes a definite contribution to the conductance of electrolyte, irrespective of the nature of other ion with which it is associated. So each ion will contribute its own ionic conductance irrespective of the other ion. So it will be not influenced by the counter ion which is associated with it. Thus, Kohlrausch law states that the equivalent conductance of an electrolyte at infinite dilution is equal to the sum of contributions of the two ions. So, equivalent conductance of an electrolyte at infinite dilution is equal to sum of ionic conductance of cation and ionic conductance of anion at infinite dilution. This is the mathematical expression of Kohlrausch law. So it is also given as lambda naught equals x into ionic conductance of cation plus y into ionic conductance of anion, where x and y are the number of cations and anions formed during the dissociation of electrolyte. So in this case, that is the 1:1 type of electrolyte, one cation, one anion will be formed on dissociation. So x is equal to 1, y is equal to 1. So in the case of barium chloride, one cation and two anions will be formed. So x will be equal to 1, y will be equal to 2. Thank you.